Alright, so today there's nothing new to learn in graphing rational functions. Content-wise, we've learned everything that we need to know. Now it's just a matter of putting all of these features together on a graph, which then I could ask you certain features of that graph. You could evaluate certain limits based off of looking at that graph, etc. So, features of a graph of a rational function that you are responsible for. First thing is finding the zeros. Finding the zeros of a rational is just like finding the zeros of a polynomial. You're going to set your equation equal to 0 and then do whatever method you need to in order to solve. Finding the y-intercepts means you plug in 0 for every x value. Okay, so zeros are going to be where we cross the x-axis, the y-intercept is where we cross the y-axis. Finding the holes in a graph, a value at which the denominator is equal to 0, but it cancels. Remember, you can factor them out. Then also you might want to write in here, find the y value so that we get a point x comma y. A vertical asymptote is a value that is the denominator 0, but it won't cancel with a factor in the numerator. And then finally our end behavior asymptotes, thinking about those limits at infinity, you either have a horizontal line or you have a slant line, both of which you would need to find, okay? So you either have horizontal or slant. Now, as a little bit of a shortcut, just a reminder for you, okay? Use the original, well, we're going to say the factored original, and that will find your domain and the x value of your holes. Using the simplified version, so after you've canceled things out that simplify down, to find the y value of the hole, the vertical asymptotes, and the end behavior asymptotes. Okay, so just a little reminder, first thing you want to do is always factor the top and the bottom. From that factored form, read the domain and the x values of the holes. Then, cancel stuff out that cancels and use the simplified to find the y value of the hole, the vertical asymptotes, and the end behavior asymptotes. Alright, so sketch a graph without using your calculator. We're going to do our best, and at the very end we're just going to check the picture to make sure we connect all of our features correctly. So, first thing always is to factor the top and the bottoms. This is going to be 2 x squared minus 9 over x plus 2, x minus 2. Well, x squared minus 9 is a difference of squares. Okay, so from this version right here, we would want to read the domain if it asked for it, and we would want to find the x values of any holes. Well, looking here, is there anything that creates a hole? Hopefully you said no. So right here we can write not available, we can write no solution, we can write no, let's not say no s, just no holes, anything of the sort. Okay, there are no holes, but you do need to tell me that there are not any. Then we would simplify this. Is there anything that cancels? No, there's not. So, vertical asymptotes are going to be where the bottom is equal to 0. So we've got the line x equals -2 and the line x equals 2. Horizontal asymptote or slant asymptote. This we want to think about top heavy, bottom heavy, or even heavy. You can look from here and see that this is going to be an even heavy function because you're going to get x squared in the top and x squared in the bottom. But in the top you also have a coefficient of 2. So looking here, we can say our horizontal asymptote is going to be at y equals 2. There is no slant asymptote. Our x-intercepts are going to be when we set this whole thing equal to 0. So if I set this equal to 0 and I multiply both sides by x plus 2 and x minus 2, then really what I get is 2 x plus 3, x minus 3 is equal to 0. Well, that means that x equals -3 and x equals 3 are my zeros. A y-intercept is when I plug in 0 for x. So I'm going to choose to plug in 0 for x here because it's a little bit easier to read. So So 0 over 0 right there, so this is going to be 0 minus 18 over negative 4. This will be the point 0, comma, 9 halves. Alright, so on your graph, we expect you to be able to plot your vertical asymptotes. So we've got a vertical asymptote at negative 2 and 2. You should be able to plot your horizontal asymptote, which we've got a horizontal asymptote at y equals 2. We do not have a slant asymptote. We have an x-intercept at the point negative 3, 0. We have an x-intercept at the point 3, 0. And we have a y-intercept at the point 0, 4.5. Now, you should be able to graph all of those things, okay? And then at the very last step, use your graphing calculator to connect the dots. So in your y equals, go ahead and type in the original, 2x squared minus 18 divided by x squared minus 4. And we can sketch in our function. So this piece right here, running along our asymptotes, this piece up here, running along our asymptotes, and this piece down here. Now, on a test or a quiz, we'll be looking for plotting all of the key features, which is all of this stuff, and then you can use your calculator to help you connect all of those things. But we should see clear points and clear asymptotes drawn in. Alright, this one I'm going to have you change slightly, just so that conversation gets a little bit better with it. I want you just to write this as x squared plus x. I'm sorry about that. I didn't print your packets. I printed your packets too early. But first up, we are going to factor this. This is going to be x times x plus 1 over x minus 2 and x plus 1. So from right here, you would read your domain. And you would read your, so domain would be x can't be equal to 2 and x can't be equal to negative 1. You would also read your holes. Well, there's going to be a hole when x is equal to negative 1. Then, now that it's simplified, we're really talking about the function x over x minus 2, all of those behaviors. So if I plug in negative 1 here to help me find this hole value, I'll write this in purple, I'm going to get negative 1 over negative 1 minus 2, so it's going to be negative 1 over negative 3, which is 1/3. Now, looking at this function, I can start doing all of the rest of my analysis. Okay, vertical asymptote is going to be at x equals 2. Horizontal asymptote, this is x to the first over x to the first, so I'm going to read from the coefficients. This will be the line y equals 1. There is no slant asymptote. My x-intercept is going to be when I plug in, or when I set this equal to 0. So if I set x over x minus 2 equal to 0, multiply both sides, that's just going to be the point 0, 0. Well, the point 0, 0 is going to be my y-intercept as well, because I'm plugging in 0 for x, I get back 0 for y. So again, plotting all of your key features. I've got a point at 0, 0. I have a hole at negative 1, 1/3, so it's going to be an open circle. A horizontal asymptote at y equals 1, and a vertical asymptote at y equals 2. Now, knowing the shape of rational functions and thinking a little bit about how to literally connect the dots, you should start to think that this is all going to connect and run to the asymptotes. Well, I can't have anything up here because that wouldn't be a function, okay? This part is going to be the other part of my reciprocal parent function that's been moved over there. Now again, I expect you to be able to graph the asymptotes, the holes, the intercepts, all of that. And then to check for how to connect the dots, you can go ahead and graph it in your calculator. So we had x squared plus x divided by x squared minus x minus 2. Go ahead and graph. Obviously it's hard to see the hole on your graph, but if you pressed trace and you pressed negative 1, there is in fact a hole because of that blank space right there. Okay? Last one. Sketch a graph without using your calculator. Graph all of these key features. So first step, factor. We're going to get x minus 2, x plus 1 over x minus 1. From here, read your domain. Well, x can't be equal to 1. See if there's any holes. Is there anything that cancels? No, there's not. So this is none. So this is our simplified version. This is what we're going to read from and do the rest of our analysis. So vertical asymptote, when the bottom is equal to 0, it's going to be the line x equals 1. Horizontal asymptote, well, this is a higher power than this one. If you multiply these together, you get x squared. This is x to the first, which means that there is no horizontal asymptote, but instead we need to find the slant asymptote, right? Because top heavy, you got to find a slant. So to do that, set up your division. Remember your slant asymptote, you don't care about the remainder, we just care about this part here. So there is a slant asymptote at the line y equals x plus 0, but you don't have to write the plus 0 if you don't want to. In X-Intercepts, I'm going to set this whole thing equal to 0 and multiply both sides by x minus 1. So I get x minus 2 times x plus 1 is equal to 0. A fraction is equal to 0 when the numerator is equal to 0. That's another way to remember that. Again, a fraction is equal to 0 when the numerator is equal to 0. A y-intercept, I'm going to plug in 0 for x. Okay, and I get negative 2 over negative 1, which is going to be 2. I could also plug it in here, negative 2 times 1 over negative 1. And now it's time to plot all of my features. So, vertical asymptote at x equals 1. No horizontal asymptote, but there is a slant asymptote at the line y equals x. The line y equals x has an intercept of 0 and then a slope of 1. So there's my slant asymptote drawn in. X-intercept at 2, 0. X-intercept at negative 1, 0. Y-intercept at 0, 2. And there are no holes that need to be plotted. Well, if you think about how your asymptotes are structuring your graph and where your dots are that you need to connect, you should be able to see that our rational function is going to look like that. If you don't trust yourself on that, you can go ahead and enter it into your calculator. You've got y equals x squared minus x minus 2 divided by x minus 1. And there we go. So again, key features of the graph. If you use this list to help you find everything, you'll be okay. Zeros, y-intercepts, holes, vertical asymptotes, and behavior. When you find a hole, use your original function, okay? I mean the factored one, okay? But you're reading from this before you go through and you cross out your x values. Then use the simplified version to read the y values, the vertical asymptotes, and behavior, etc. Putting all of this together, on any of these graphs, I could ask you things like, what is the limit as x goes to negative 3? Well, that would be 0. Or on this one, what is the limit as x goes to negative 1? The limit would be 1/3, even though f of negative 1 would not be 1/3, or in this case, h of negative 1. Alright, that's it. That's the end.